Hello guys, and welcome to video number 3. This is lesson number 2 for this course, for this tutorial series. My name is Ngane Emmanuel, and you're watching a course that is titled Building Secure, Scalable, Fault-Tolerant and Low-Latency APIs with Java and Spring Boot. I'm a software engineer with multiple years of experience, and I'm making this video as a continuation from our last video. So in the last video, we talked about we introduced the concept of APIs, and if you want to know what this series is all about, you can start from the first video where I get to explain everything, right? So in this video today, we are going to talk about types of APIs, and we're going to jump right off. But before we continue, I just wanted to state that, you see, the first 3 videos will be mostly theoretical, and my slides are so how can I put it, detailed, that I'm just going to be talking about the same thing which is written on the slide. So if you look at the last video, it was 20 minutes, right? But it's not supposed to be that long, and I don't want to take like 20-30 minutes just reiterating certain things which are already on the slide. These are just notes which I put together. They're detailed, they're straightforward, and they convey the idea and the information which they are intended to convey. So in this tutorial, this particular video, I'm just going to be touching a little bit on certain things. I'm just going to read through all of this just as a rule of thumb, so that you could just put it and listen to me talk, and then go through it faster than, because some people don't really like reading. Like myself, I hate reading, so I really enjoy when people read out the notes like this, even if it's just a video that spans about 5 to 10 minutes. So this is about 29 slides, and we're going to go through them quickly, introducing the concept of types of APIs, right? So there are different types of, let's dive right in, right? Different systems have different needs, right? As you can see, we have the different needs for every system. We have performance requirements, data complexity, real-time communication, scalability, ease of development, compatibility with existing tools, right? No single API style solve all problem. That's a given. All right. In the computer field, there is a common saying that there are multiple different solutions for a given problem. Right. And that particular logic applies in API. All right. So we're going to begin right off the bat with the first type of API, which is the public APIs. Right. These APIs have as characteristics they're exposed to external developers. Okay. They're used by third-party applications, and they're usually secure with API keys, right? Something like auth and tokens. Okay. Examples of a public API, you have like payment gateways, weather service, map service, social media APIs. And the characteristics, they have very high security because they are exposed to the public. Their security is supposed to be high, and they have very strong documentations, detailed and well structured for ease of understanding for their users, right? And they implement rate limiting, which is a security measure to prevent distributed or denial of service attack or distributed denial of service attacks, right? DOS and DDoS. And then they also implement monitoring to monitor the rate of use and other aspects of the API. So that's the first one. And the second type of API, we have private APIs, right? Mostly called, in other words, internal APIs, right? So private APIs, they are used only inside the organization, right? They are not exposed to the public, right? They connect internal service and systems, right? And then they often power microservices and architecture. So for characteristics, they are fast evolution, so they easily evolve, right? They have controlled access, again, less public view, right? And then they don't also have public documentations because they are mostly used internal. You don't want to expose information about a particular API to the public, okay? And they are optimized for internal performance, as you can see. And the third one, we have a partner API. Now, partner APIs are they are shared with selected partners, right? These are APIs that organization develop and shared with partners of that organization. They are not used only for they're not used for internal purposes, and they're not public, which means not everybody can access it, but they are only just given to partners, to people who they're in business with, and they always come with access with restrictions and governed by contracts. So the access of these APIs are heavily restricted, and the way each organization is going to use that particular API is going to be governed by the contract of between that was signed between the two businesses, right? So they're used in business to business integration. Examples include logistic integration, banking integration, enterprise data sharing. So and so we have, so those are the three main types of APIs as was seen. And then we are going to look at API styles right now, and API styles, the architectural styles of APIs, right? And obviously we have seen this before. We have REST APIs, we have GraphQLs, we have gRPCs, remote procedure calls, and we have WebSockets. So we're going to start with REST API, which is stands for representational state transfer, and it is the most common API style on the web. Key characteristics: they use HTTP methods such as get, post, put, delete. They are stateless in communication. Resource and most of the time when you make this call, you're going to identify a resource by the URL. They use JSON or XML as in their payload. Okay, so a typical example of a REST API will be, as you can see here, the get, which is define the request type, and then the URL. So, and this is the resource type at the end here, which talks about the get, the products by the ID. So the product with the ID 10. So in later videos, we're going to see how to read this particular, how to create a REST API, which is what we're going to focus in mostly on this course. So we're also going to touch other APIs such as, I think, gRPC, but for now, let's move to the next. So the benefits of the REST API, they're simple, they're scalable, cacheable, widely supported, as you can see. Limitations, can overfetch and or underfetch data, right? And this is one of the very biggest limitations of REST API, especially overfetching part, which can lead to data leakage and data exposure, right? And it's not good. We're going to see this later, and we're going to see how we solve this later. This is going to be part of our introductory part of this. Will be in our introductory, around the first videos of our security measures when we implement API safety and security. So other limitations, multiple calls may be required, of course, because you're going to see in other type of API such as the GraphQL, you only require just a single call to be able to retrieve all the data that you need. So the next style is GraphQL. Client specifies exactly what the data is needed. So in the GraphQL, as you can see in the example, you simply just specify what you need, and you receive it. Now this API was developed by Facebook, and part of the problem it solves is the problem of the limitation of the REST API. By overfetching data, it can lead to data leakage. So the GraphQL allows you to just return just the data which was requested, and it prevents overfetching and exposure. So benefits: precise data fetching, fewer network calls, strong schema validation. Limitations: more complex infrastructure, caching is harder, learning curve, right? So there is a bit of a learning curve there. So we have gRPC, also called Google Remote Procedure Calls. Although it's open source now, the G changes. Some people just say general purpose remote procedure call just because it's now open source. Well, it has it's a high performance binary protocol, which is very good in usage between microservices, internal use between service to service. It is not really advisable just because it is really difficult to understand when developers use it, and it's only very advisable to use in service to service communication, as it's ideal in that way. All right, so characteristics: uses protocol buffers, strong typing, very fast serialization, which we are going to see, ideal for microservices. gRPC, the benefits of gRPC: extremely fast. That's one of the highest benefits, and that's why it's used between service to service, because when you're making a remote procedure call from one service to another, you want that particular communication to be very fast. It should simulate as if you're just making a call to a particular class within the same repository. So it's efficient network usage. You can It uses, I think, HTTP/2. Yeah. Limitations, not human readable. Yes, that's what I'm talking about. And so it's difficult for developers to work with. Browser support is limited, harder to debug. So WebSocket is another style of API, API style, architectural style. WebSockets are used for real-time bi-directional communications, right? Such as chat applications, live dashboards, multiplayer games, and real-time monitoring. Even like in trading, right? No, not in trading. Let me just say, well, yes, like in trading where you need where every second counts, right? You're talking about live data, right? Mostly it's WebSocket, right? Because you really want the data to you want to receive the data immediately. The data shows, right? So no delay there. You benefit low latency, continuous connection, and WebSocket basically, if you don't know, it establishes an open connection between two parties, right? Between two applications, you have a single open connection. You have an open connection, and that open connection is never closed. And so immediately data arrive on one end, the other end receives it too. So um, limitation, more complex scaling, connection management overhead, obviously. So when to use what, right? So REST APIs, of course, the most widely used are used among web and mobile applications. GraphQL, complex data requirements, and that's when you want to fetch from multiple different database tables on a particular database. Let's say like that. Um, let's at least look at it from that point of view. And because for REST, when you're going to be making multiple requests to be able to attain the same result which you can use with GraphQL. So for gRPC, high performance internal services, again, service to service communication is very ideal there. WebSocket, real time system, of course, so that you get update as soon as they are made. There is no universal best choice, right? And sometimes, in fact, in most of the cases, you're going to see in application can use all of them or a number of them. It only just depends on what the problem you're trying to solve is and when to use both. But these are just the best instances to use both. So we're going to see in this particular series, we're going to see REST, we're going to see gRPC, and maybe I might demo maybe towards the end WebSocket just for demo sake, because we're going to be working with very basic applications, right? So might not need this. GraphQL too is not going to be required, but it's always nice to know so you can do more research. We can maybe I might be able to touch it, but we'll see. Important clarification, right? An API is not just controllers. Like, as earlier stated in the last video, and I think, right, it's not just like the controller layer. API is it's a full system, right? Composed of multiple layers: the controller layer, the business layer, the database layer, right? Most production APIs follow the layered architecture, and this is a typical architecture of the layered. So it is a typical layered architecture of an API. So we're going to have the clients here, so our mobile app order services, that's external services. Well, these are other services that may call this API, just like your clients. And we're going to have the API layer, which is the controller layer. This is where your API endpoints lie. Again, as you will see, endpoints are not the API, it's just part of the API. And we're going to have the business layer, the business logic layer, where we cite all your business logic, your processing, and everything. We're going to have the data access layer, which you're going to use to access data from your databases and external services. And that's the typical architecture of an API. Most business, even even organizations producing large scale applications, they use this particular structure because it's the most efficient and it's easy to maintain, easy to scale, easy to use, easy to understand. It's proven and it works, right? So API layer, we're going to talk about responsibility. It receives the HTTP request, it validates input, it maps request to business logic, it returns HTTP responses, it handles status code and errors. All right, so those are the responsibilities of the API layer, which is the controller layer. In Spring Boot, we're going to use the annotation REST controller because we're going to be creating REST controllers. So to create that layer, the controller layer, we're going to use the annotation REST controllers. Again, we're going to be using Spring Boot in this course, so if you are not familiar with it, it's advisable to be, even just a little bit. Else, don't worry, we're going to be trying to make it as easy as possible. Okay, defines endpoint. This layer should be thin. It should not contain business logic in it. It's just like get the request and route it to the particular business layer, the particular service that needs to handle that request, and that's all. And get the response from that service and return the response to the customer, to the client. And no logic there, no validation. I mean, well, not you do validation there, but no business logic, processing, and all that stuff. So business logic layer, this is where, of course, the core business rules are being put, the validation logic, as you can see, the transactions, the orchestration of multiple repositories or services, security checks sometimes are done here, right? Although you can do security checks in the controller layer, as we can see. We're going to be doing some basic security checks we're going to see later in this video, like authentication at the controller layer, which we're going to catch requests as they're coming in and then validate those requests before sending them to their respective controllers. We're going to use, in Spring Boot, we're going to use the service annotation for annotating service layers, and this is where most application logic live. The data access layer, which is otherwise called also called the repository layer, responsibilities include interacts with the database, executes queries, map entities to tables, handles persistence. In Spring Boot annotations, in Spring Boot we annotate these layers with the repository annotation. It uses PA, gRPC, or other persistent tool. Right, so yeah, we're going to see that later in this particular series. We have external dependencies. API often integrate with databases, message brokers, cache, third-party service authentication providers, of course. And this is where, you know, most some of the calls, the remote procedure calls, may occur if you are using like third-party services, or even like to your other services, right? You're going to have such things like that. Even like authentication providers, right? You're going to make requests to those APIs. So we can use different architectural styles there. So these dependencies must be handled carefully for reliability and performance. Now, what is MVC? Because why I included it here, because MVC bears some resemblance, and sometimes some people get to confuse MVC versus layered architecture, especially when it comes to how APIs are used, right? Because if you look at the Spring Boot, we have the, you know, sometimes you have aspects of the MVC in a layered architecture, and even in the Spring Boot. And so MVC stands for Model View Controller. It's mainly used for UI-based application. And when you're building like a web application that also have like an API backend, yes, the MVC is used for it. And API itself has some aspect of MVC that it uses. So, but why MVC is not a perfect use to describe an API is API usually do not return the view, and that's one of the main reasons, right? API returns data in JSON and XML, and the view concept does not really apply here. Business logic should not live in a controller again, because the closest you get is the controller that returns data. How API actually uses the MVC concept, and as you can see, we have the controller, right? So because the MVC is going to have the MVC is model view controller, and so the controller for the MVC model is going to tie in as the API layer in the layered architecture for APIs, right? And the model is going to tie to the data objects, the DTOs, and the entities. We're going to see this later in the series, and the view, which is not applicable here. So most APIs evolve in a layered architecture, not just pure MVC. So correct mental model. So you think of it in layers, not screens. API layer, business layer, data layer, infrastructure layer. This improves maintainability. And you may be why I'm really iterating this is so that you understand that this is more of a layer. And you might seem all this chat here might seem like a waste of time, but believe me, it's very important because a lot of people really confuse this. What many people think, right? The API is just the endpoint. Well, again, like I said, API is not just the endpoint. The endpoint is part of the API, and it rests in the API layer, which is the controller layer. Right, so we have examples of endpoints. These are endpoints, but this is not an API. Again, this is something that people often confuse. This is called an API's endpoint, but this is not an API, right? This is just an access point through which you get to send requests to the API. You get to talk to the API. So an API includes, right, endpoints, validation rules, business logic, data models, error handlings, security mechanisms, documentations, performance behavior, reliability behavior, and so on. Right. So we have endpoints are just like entry points. Again, very important to keep in mind. These are simple things that easily confuses people. But again, endpoints are not APIs in a whole. They're just part of the APIs, and an API includes so much more. Why this matter? If you focus on endpoints, security becomes weak, performance suffers, scalability breaks, fault propagates easily, right? Real engineering happens behind the endpoint. Again, so the endpoint is just in the controller layer. Most of the business logic hides in the service layers. That's the business layer, right? And also you talk to database through the database layer, the repository layer. So key takeaway: API come in multiple styles for different needs. REST is common but not the only choice. APIs use layered architecture, and this is not the same as API architecture. Endpoints are only part of an API. These are very important, simple, straightforward, and give you all you need to know about API. So in the next video, we are going to be, well, this will not come in the next video, at least this first point. In the next video, we're going to talk about basic API concept, good practices on how to design an API, and so it's after that video that we're going to see designing a very basic API, understanding controllers, services, repositories, right? Creating a minimal Spring Boot project and seeing how layer interacts. And why is because, so why I have this here is that I created this slide and had this on there before I realized that I skipped one particular important lecture on creating APIs. So I made that video, which is what is going to come after this one, where we're going to talk about API designs, right? It's very important, and mostly we're going to focus on about the REST API design. So I hope you like this particular tutorial. Again, this is really long, but what we skimmed through, so it did not take us too long, not 30 minutes. We are below 25 minutes or 29 slides, and I hope I explained the concept well. If you have any worries, comment in leave your comment in the comment section, and I'm going to get back to you as soon as I can. Connect with me on my social media platforms using the link in the description below. Also, subscribe to the channel, click the notification bell to make sure that when I upload new videos in this series, you get a notification immediately and you can be the first to watch. Share this video to those who you wish to learn more about this particular series, as we have some very interesting topics coming up, and believe me, it's going to be an amazing series, and by the end of the series you're going to be a master of API. So if you are watching that you're enjoying it, I will really appreciate your engagement in these videos. Even leave me a comment on the social media, write a post, tag me in it, and I'm going to respond as always. So thank you for watching, and as always, I've been Ngane Emmanuel. Until next time.